So we're going to look at solving inequalities. Solving inequalities is almost exactly the same as solving equations. In fact, I'm going to use my do and undo chart quite a bit today because, like I said, it's almost exactly the same. What is the difference between solving equations and solving inequalities? Well, there's a special rule you have to remember. And that special rule has to do with multiplying and dividing by negative numbers. And the rule is, when you multiply or divide by a negative, you have to flip the inequality symbol. Because remember, negative make things opposite, and so we need to make the symbol opposite as well. So let's look at some examples, practice our do and undo, and also remember that when we multiply and divide by a negative number, we need to flip our inequality symbol. We don't have to flip it all the time, just when it's negative, so keep an eye out. So we're going to solve the inequality x minus 5 is less than or equal to negative 14, and then we're also going to graph it. If you forgot about graphing, you can look at the other inequalities video, Inequalities Basics, and you can get a recap on that. But solving means I need to make my do and my undo chart. So x minus 5, the first thing that's done to x is minus 5. So what would you do to undo minus 5? We would add 5. So just like when I was solving equations, I'm going to draw my line, and I'm going to follow my chart. I'm going to add 5 to both sides. Plus 5, plus 5. So I end up with the statement x is less than or equal to negative 14 plus 5 is negative 9. And I'm done. So I think. We also want to graph this. And when we graph inequalities, we graph on a number line. So I'm just going to draw a little easy number line right now. And I want to graph all of the numbers that are less than or equal to negative 9 because x could have many answers. Anything smaller than or equal to negative 9 would make it true. So I need my boundary. I need my negative 9. There he is on my number line. Need to decide whether or not to color him in. Can x equal negative 9? Yeah, so I need to color it in. Now I'm looking for all of the numbers that are less than that are smaller than that, and smaller is to the left. So I'm going to shade over here to the left, and I've graphed my solution inequality, which is x is less than or equal to negative 9, which means any number down here could make this inequality true. Alright, so here's another one. I'm going to use my do and undo chart one more time. Do, undo. So what is being done to x in this equation? Looks like it's being divided by negative 2. And that's it. So what we need to do is we need to undo that, and undoing that is multiplying by negative 2. Multiplying by a negative. I think I remember something about that. Remember what we need to do when we multiply by a negative. So let's go ahead and let's do that. Undo says multiply by negative 2. I'm going to multiply by negative 2 on both sides. Oh, I'm multiplying by a negative. So that greater than symbol needs to flip, and it needs to become a less than symbol. So here we had to undo. We're left with x. 8 times negative 2 is negative 16, and we're done. X is less than negative 16. We needed to flip that inequality symbol because we multiplied by a negative. Now we can also graph that. I'm going to draw my number line. I'm going to draw my boundary. My boundary is negative 16. Is it okay if x is equal to negative 16? Nope. So we have to keep it open. Now, we're looking for all the numbers that are smaller than negative 16, and on a number line, smaller numbers come to the left. So I'm going to shade to the left, and I'm done. This inequality has a few more steps to it, so we want to make sure to do our do and undo chart on this one. I'm going to focus on the side that has the variable on it, and in this case it's p. 5 plus p divided by 2. So the first thing that got done was we added 5 and p, so plus 5. Then what was the last thing we did? We divided by 2. So when I make my undo chart, I'm going to use a different color. I'm going to do the opposite. The opposite of dividing by 2 is multiplying by 2. The opposite of adding 5 is subtracting 5. We do it in that opposite order. So, drawing our line down the middle, I'm going to multiply by 2 and multiply by 2. Now, this is an inequality, so I'm on a lookout for weird things. When I multiply by a positive number, do I need to worry about flipping the sign? Nope. So we can just go ahead and solve it. 10 times 2 is 20, greater than 5 plus p, because those canceled out. That was my undo step. Now my next undo step, my last undo step, is to subtract 5. I'm going to subtract 5 from both sides. So we have 20 minus 5, which is 15, is greater than p. Now, I don't really like to graph when it's in this form, so I'm going to flip them over. And when I say flip them over, I'm going to take this entire thing and I'm going to flip it over like I'm flipping over a blanket. It's really hard for you to see what I'm doing, but I'm flipping my hands right now like a blanket. The p is going to come on this side. The 15 is going to go to that side. And the inequality symbol is also going to flip over. It's pointing at p here, so it needs to point at p here. This is what I actually want to graph on my number line. P is less than 15. So I'm going to put my boundary here, 15. Then I'm going to circle, can P equal 15? No. So we leave it open and we shade to the left because numbers that are smaller than are to the left. Alright, I thought I'd give us a crazy one because we're getting pretty good at the inequality stuff and we want to remember how to solve. Now this one has a lot of things going on and I have lots of x's, so I cannot make my do and undo chart yet. I need to get rid of my parentheses and combine like terms first. So that means distribute and combine like terms. So let's go ahead and distribute here with those parentheses. 5 times x is going to get me 5x. 5 times 3 is positive 15. I still have that plus 3 hanging out there. We don't want to lose him. Alright, nothing changed on that side. Now we need to combine like terms. So I have a 15, it's a number, a 3, and that's a number, so we can combine those. So 5x stays the same, he has nobody to go with right now. Those get added together and make 18. So far again, nothing's changed on the left. Now, though, we're ready to start gathering things together. We need to move our x's all to the same side. I like to move them to the left, so that's what I'm going to do. I'm going to move that 5x. I don't want him anymore. I'm going to remove him, minus 5x. But remember, we need to keep things balanced, so we need a minus 5x on the other side. So I have negative 4x's and negative 5x's. Altogether, we have negative 9x's. On the other side, those canceled, and I'm left with 18. Alright, now I'm not even going to bother to make my chart because I know you guys can tell me exactly what I need to do to solve this. Divide both sides by negative 9. Oh, what did I just do? Divided by a negative. What do we need to remember to do when we divide by a negative? Flip the symbol. So I'm going to flip that over. I'm going to be left with x on that side, and I'm going to be left with 18 divided by negative 9, which is negative 2. I'm going to go ahead and I'm going to graph this one since it's finally a greater than. I'm going to mark my boundary as negative 2. I'm going to put my circle there. In this case, is it okay for x to equal negative 2? Yes, because x can be greater than or equal to negative 2. So we're going to color it in and shade to the right because the greater numbers are to the right. Where inequalities start to get a little weird is when you have to deal with a word problem. So let's go ahead and let's see if we can figure out what inequality symbol we would use in this word problem. It says Kevin has $34 and he wants to buy snacks for his soccer team. Food costs $10. There are 15 players on the team. How much can each drink cost so that Kevin can buy one for each member of his team? So it looks like that each drink, that's gonna be our variable. So I'm gonna use the letter D for my drinks. Alright, now Kevin's spending some money. He has food that costs $10. And then each drink, well, how many drinks does he need to buy? 15. So he's going to spend $10 plus however much drinks cost for 15 players. So when we write our equation, he's going to spend $10 and 15 times however much a drink costs. Now Kevin has $34, so that's sort of like our equals to part of the equation. But here's what we need to think about. We know about inequalities. Kevin is going to spend some money, and he has $34. What do we know about the money Kevin can spend in comparison to the money he has? He has 34. Can he spend more than that? No, he needs to spend less than that. So the money he needs to spend is less than 34. Is it okay if Kevin spends all of his money? Yeah. So it could also equal 34. So, food costs $10. Drinks are 15 times however much a drink is. And he needs to keep that under or equal to $34 so that he doesn't run out of money. So now let's go ahead and let's solve it and find how much these drinks cost. We need to get rid of that 10 because it has nothing to do with the drinks. That's the food. So let's subtract 10 from both sides. So we get 15D is less than or equal to 24. Alright, now we have to do a little dividing. We have to divide both sides by 15. Alright, so 24 divided by 15 is kind of gross. Pull up the calculator on your computer and see if you can do it. I'm going to assume you guys all did it. So, left with D on this side, no negatives, so I can say is less than or equal to 24 divided by 15, which is 1.6. So, in Kevin's case, drinks need to be less than or equal to 1.6 each. So, they need to be less than $1.60. Alright, we're almost done. 2 more to go. So here we have Steve. Steve's question is off the page. Now it's not. Steve, the average of Steve's 2 test scores must be a 90 in order to make an A in class. So, average, he's got 2 test scores, and it has to be a 90 to make an A in the class. He earned a 92 on his first test. We need to know what scores he could earn in order to reach his goal. So here's where inequalities are pretty important. It says what scores could he earn. So he has a lot of different options as to what he gets to get a test average of at least a 90 in his class. And so it's important to have an inequality as opposed to an equals, so that way we can figure out which are the possibilities, not just which is the one he needs. So, when we're finding averages, you add things together and divide by however much there are. So it says 2 test scores. So we know one of his test scores is a 92. Plus his other test score, I don't know what it is, so I'm going to call it X. Now averaging divided by how many there are means divided by 2. And his goal is to have an average of 90. Now it says he has to have a 90 in order to make an A. But what else could his grade be and still make an A? Anything bigger than 90, right? So I'm going to do greater than or equal to. So the average is greater than or equal to 90. Now we're going to go ahead and solve it. This one's a little bit tricky, so I'm going to make a do and undo chart. If you don't need one, don't make one. 92 plus x. So the first thing that's done is adding 92. Divided by 2. So when we make our undo column, we are going to undo by multiplying by 2, undo by subtracting 92, because we do it in that order. I'm going to draw my line, and we're going to go ahead and do these steps. Multiply both sides by 2. 92 plus x is greater than or equal to 90 times 2, 180. And next step says I need to subtract 92 from both sides. So x needs to be greater than or equal to 180 minus 92. Get that calculator again, which is 88. So Steve can score anything greater than or equal to 88, and he can get his A. So think about this. Steve could get an 88. What else could Steve get on his test? Steve might do something awesome and get a 97 on his test, right? Steve could get a 89 on his test. Steve could get anything bigger than or equal to 88 and still reach his goal of having an average of at least a 90. Okay, this is the last one. This one is going to have variables on both sides. So we're going to look at them piece by piece. First we have Ty. Ty earns $7 per hour and has $20 in the bank. So if we were wanting to write an expression for Ty, 7 per hour, 7x, or h, let's use h, I feel like using h, and $20, that's Ty. Now we have Mario, let's use a Mario, he'll be red. Mario is earning $5 per hour, and he already has $100 in the bank. So Mario would be 5h plus 100. Now, I want to know how many hours it will take for Ty's money to be greater than Mario's money. So I'm glad I used these colors here. Ty's money, Mario's money. We want to compare them. We want the green to be greater than the red. Now, I'm going to go back up. I already know what the green represents. The green is Ty, and Ty is 7h plus 20. The red is Mario, and we already figured that out too. Mario is 5h plus 100. So we have an inequality with variables on both sides. No problem. Let's go ahead and let's solve it. I'm going to draw my line. I can't do my do and undo yet because I have h's all over the place. So I need to get my h's together, and I'm going to get a different color. And then I'm going to move those 5 h's. I don't want them over there anymore. I want to move those 5 h's to the other side. So get rid of them there. Got to keep it balanced, so get rid of them there. 7 h's minus 5 h's is 2 h's. Alright, so now we have 2h plus 20 is greater than 100. We can go ahead and do some more solving. We can get rid of that 20. It doesn't have anything to do with h, the hours. So I'm going to subtract 20. Now we have to keep it balanced, so I'm going to subtract 20 on the other side as well. So looks like now we're at 2h is greater than 80. One last step. We got to get h by itself. I'm going to divide both sides by 2, and h is greater than 40. So the question was, how many hours will it take for Ty's money to be greater than Mario's money? 40 hours, is that the answer? No, because the hours has to be greater than 40. So as soon as Ty works for more than 40 hours, she'll start having more money. So Ty could work for 41 hours. Ty could work for 50 hours if she really wanted to. She just needs to work a number of hours that's greater than 40 in order to be greater than Mario in terms of money. So that was solving inequalities.